Right now, a spacecraft launched in 1977, older than most of your parents, is still sending signals from beyond our solar system. On November 15, 2026, Voyager 1 will cross a milestone no human-made object has ever reached, so far that a radio signal takes a full 24 hours just to arrive. It was built with computers 3 million times less powerful than your smartphone, and it is still talking to us. I remember reading that if you sent Voyager 1 a good morning message on a Monday, you would not hear its reply until Wednesday. That single fact stopped me completely. We built something in 1977 that is so far away it takes 2 days just to have one conversation with it. Voyager 1 and 2 launched in 1977 to take advantage of a rare alignment of the outer planets that only happens once every 176 years. A gravitational highway that let a single spacecraft visit multiple planets using almost no extra fuel. Voyager 1 launched on September 5, 1977. Its original mission was just 4 years, a flyby of Jupiter and Saturn. Nobody planned for what came after. The planetary alignment they used in 1977 will not happen again until 2153. If NASA had missed that window, there would have been no Voyager mission as we know it. In March 1979, Voyager 1 flew past Jupiter and changed planetary science permanently, discovering active volcanoes on the moon Io, the first time volcanic activity had been confirmed anywhere beyond Earth. Voyager also confirmed that Jupiter has a faint ring system, something no telescope on Earth had detected. It photographed lightning in Jupiter's atmosphere and discovered 3 new moons in a single flyby. The data Voyager sent back from Jupiter took 43 minutes to reach Earth at the speed of light. Engineers on the ground had to wait almost an hour just to know if each command had worked. Voyager 1 reached Saturn in November 1980 and revealed its rings in detail never seen before: thousands of separate ringlets, braided structures, and a ring with a twist that physicists could not immediately explain. Voyager discovered that Saturn's moon Titan has a thick atmosphere, the only moon in the solar system confirmed to have one. This finding directly shaped the design of ESA's Huygens probe, which landed on Titan in 2005 after the Saturn flyby. Voyager 1's trajectory bent upward out of the planetary plane, sending it on a permanent one-way path toward interstellar space, with no more planets to visit. Its planetary mission was over. Its real mission had just begun. On February 14, 1990, astronomer Carl Sagan convinced NASA to turn Voyager 1's camera backward one last time. At a distance of 6 billion kilometers, it photographed Earth, a tiny pale blue dot in a vast beam of scattered sunlight. Earth appears as 0.12 pixels in that photograph. The image was taken from the equivalent of about 40 astronomical units, 4 times farther than Pluto. Shortly after taking that photograph, NASA shut down Voyager 1's cameras permanently to conserve power. That image of Earth remains the most distant photograph of our planet ever taken. No spacecraft has taken a farther one since. On August 25, 2012, Voyager 1 crossed the heliopause, the boundary where the sun's solar wind stops and true interstellar space begins, becoming the first human-made object ever to leave the heliosphere. NASA confirmed the crossing through plasma wave data. The density of charged particles around Voyager 1 jumped sharply, exactly as models predicted for the transition from solar to interstellar medium. Voyager 2 followed in 2018, crossing from a different direction, allowing scientists to compare readings from 2 separate entry points into interstellar space for the first time. As of 2026, Voyager 1 is approximately 25.9 billion kilometers from Earth, 170 astronomical units out, moving at 17 kilometers per second and still transmitting. It is the most distant human-made object in existence. 2 science instruments remain active on Voyager 1, the plasma wave subsystem and the magnetometer. These 2 instruments are measuring the magnetic field and plasma environment of true interstellar space. data no other spacecraft has ever collected. Voyager 1 transmits at 160 bits per second, equivalent to dial-up internet from the 1980s. NASA needs multiple antenna arrays across 3 continents just to detect that faint signal from 25 billion kilometers away. On November 15, 2026, Voyager 1 will reach 1 light day from Earth, the exact point where a radio signal traveling at the speed of light takes 24 hours to arrive. NASA has confirmed this date precisely. NASA's Voyager project manager Suzy Dodd described it clearly. If she sends a good morning command on Monday at 8 a.m., she will receive Voyager's response on Wednesday at 8 a.m. Every single command now takes 2 full days to complete. No human-made object has ever been this far from Earth. Voyager 1 will be the first, and it will hold that record indefinitely. The next closest spacecraft, Voyager 2, will not reach this distance until approximately 2035. Voyager 1 is powered by 3 radioisotope thermoelectric generators, devices that convert heat from decaying plutonium-238 into electricity. They lose approximately 4 watts of output every year. To stretch the remaining power, NASA engineers have been systematically switching off heaters, instruments, and systems in a carefully chosen order for years. The cameras were turned off in 1990. More instruments followed in 2025. NASA expects Voyager 1's power to drop below the minimum threshold needed to operate any instrument in the early 2030s. After that, the spacecraft will continue traveling, but in complete silence. Only one antenna in NASA's Deep Space Network can send commands to either Voyager, Deep Space Station 43 in Canberra, Australia. It is the largest steerable dish in the Southern Hemisphere at 70 meters wide. From May 2025 through February 2026, DSS-43 was offline for major upgrades, creating a period where NASA could only receive signals from Voyager, not send commands. Brief operational windows in August and December 2025 allowed limited communication. This single point of failure, one antenna, one location, one team, is what stands between continued contact with humanity's most distant spacecraft and permanent silence. Bolted to the outside of both Voyager spacecraft is the Golden Record, a gold-plated copper disc containing greetings in 55 languages, music from multiple cultures, sounds of Earth, and scientific diagrams showing how to find us. The record was designed by a team led by Carl Sagan. It includes a map showing Earth's position relative to 14 nearby pulsars, chosen because pulsar timing is a universal reference point that any sufficiently advanced civilization could decode. The Golden Record will outlast every human structure currently on Earth. Voyager 1 will pass within 1.6 light-years of a faint red dwarf star called Gliese 445 in roughly 40,000 years, carrying that record with it. Before Voyager crossed the heliopause, scientists had no direct measurements of interstellar space. Every model was theoretical. Voyager 1 gave us the first real data, and it immediately challenged several predictions. Voyager confirmed that the interstellar medium is denser and hotter than many models predicted. The magnetic field at the boundary was also more complex, creating what scientists described as a turbulent, foam-like region rather than a clean line. Southwest Research Institute scientists are still actively using Voyager data combined with NASA's New Horizons spacecraft to map where the outer boundary of the heliosphere actually lies. Research published as recently as July 2026 in the early 2030s. Voyager 1's power will drop below the threshold needed to run any instrument. NASA will receive its last data transmission, and then silence. The spacecraft itself will keep traveling forever. At its current speed of 17 kilometers per second, Voyager 1 would need approximately 73,000 years to reach the nearest star, and it is not even heading toward it. It is heading toward the constellation Ophiuchus, with no destination. What Voyager 1 will be forever is the longest surviving artifact of human civilization anywhere in the universe. Long after everything we have ever built is gone, it will still be out there. That is tomorrow's science.